This is the second video about linked lists in C. Click above if you haven't seen the first. In that one, I covered what a linked list is, the structures we needed for the list, adding nodes at the head or tail of the list, and printing the contents of the list. In this one, I'll cover finding a particular node in the list, inserting nodes in sequential order to keep a list sorted, and deleting a particular node from the list. To find a node in the list, we're going to walk through the list using the next pointers, just like we did for printing a list. However, this time, our sentinel controlled loop should stop if we find the null we're looking for, or if the pointer we're using to walk through the list walks off the end and becomes null. Let's watch this work on this list and say we're looking for a player ID of 13. So, our call on find would look like this. We're going to use a local variable p to walk through the list, so we start it where the list's head is pointing. We check our condition, p is not null, and player ID it is pointing at is 42, which is not the one we're looking for. So, we copy p's next pointer into p, check the condition again, still not null, and 56 is not the player ID we're looking for. So, copy p's next pointer into p, check the condition again. This time, p's player ID is the 13 that we're looking for, so the loop stops and we return p. In all list operations, we have to think about special cases. In this case, what happens if the list is empty? Well, when we first create p, if the list is empty, list points to head will be null. So p will be null. So our loop will stop right away and will return null. Having a return of null mean that we didn't find what you're looking for makes sense. So that's okay. The other special case to think about is what if the list isn't empty, but it doesn't contain the player we're looking for? In that case, the loop will run all the way through the list. At the last node, when we copy the next pointer into p, we'll be copying that null pointer into p. That'll stop the loop since p is null. And when we return p, we'll return null, which means we didn't find what we were looking for. Both special cases are handled by this code. Sometimes we want to keep a list in sorted order, so we don't want to add at the head or the tail. We want to insert new nodes at the right place so that we maintain that sorted order. In our case, let's say we want to keep our list sorted by player ID. We start by creating a new node to hold the information we're inserting. And then there are just a few cases we have to worry about. First, let's do the easiest insert. If the list is empty, the head pointer will be null, and we just need to make both the head and tail pointers point at the new node. That was easy. Once we know the list isn't empty, we need to search for where the new node should go. As a general strategy, we want to walk through the list until we find a node that is bigger than the one that we're inserting, and then hook the new node between that bigger node and its predecessor. For example, if we wanted to insert a node with a player ID of 58 into this list, we'd want to walk through the list until we found player ID 63, the first one that is bigger than 58, and hook the node between the node with player ID 56 and the node with player ID 60. Well, that's good in philosophy, but the details matter. When we're walking through the list, we end with a pointer to the node that will follow the new node, and we can make the new node point to that. But there's no way to find the node with player ID 56 to make its next pointer point at the new node. To fix that, when we walk through the list, we're going to make one pointer search for the insertion point, and we're going to keep one pointer one node behind that first one. So, cur is walking through the list looking for the first node that is bigger than the one we're inserting. Before we move cur, we save it in prev. That makes prev always be one node behind cur in our search. I think we should watch that work. We start with prev equal to null and cur pointing at the first node. Cur's player ID is less than the one we're inserting, so we move prev to where cur is, and then move cur to cur's next pointer. Cur's player ID is still less than the one we're inserting, so we do it again. Move prev to point where cur is pointing, and then move cur to cur's next pointer. Now player ID is 63, which is bigger than 58, so the loop stops. Now we can hook the new node in by making the new node's next pointer point where cur is pointing, and make prev's next pointer point at the new node. And the list is still ordered by player ID. Now, there are some special cases that we need to worry about. In particular, we have to worry about when we are inserting at the beginning or ending of the list, because in those cases, we're going to have to fix up the head and tail pointers too. If the value that we're inserting is less than everything in the list, the loop will stop before we move cur at all, so prev will still be null. If that's true, then we essentially want to do an added head that we talked about in the last video. Make the new node point to where the head points, and then make the head point at the new node. Similarly, if the node that we're inserting is greater than everything in the list, the loop will run all the way off the end of the list, so cur will be null. And we want to handle it just like we did added tail in the last video. Make the tail's next pointer point at the new node, and then make the tail point at the new node. Deleting a node is a lot like inserting a node. We need to find the node that we want to delete, and then unhook it from the list. That unhooking is going to require that we have a pointer to the previous node, just like we needed for insertion. Therefore, we're going to have a loop that moves prev and cur, just like the loop in insert. The only difference is that the loop will stop when cur points at the node that we want to delete, and then all we have to do is copy cur's next pointer into prev's next pointer. That unhooks the node from the list, and we can free it and return true so that the caller knows that we successfully deleted it. However, there are 3 special cases we have to worry about. First, if we walk off the end of the list, cur will be null, and that means that we didn't find the node that we were supposed to delete. We can output an error and return false so that the caller knows that we couldn't do the delete. The other 2 special cases, again, involve when we need to move either the head or the tail pointer. If we have to delete the first node in the list, the loop won't have moved anything, so prev will still be null. In that case, we need to copy the head node's next pointer into the head to move the head past the node that we're deleting. Similarly, if we're deleting the last node in the list, cur will be equal to the tail pointer, and we need the tail pointer to point to prev so that it points to the last remaining node in the list. At this point, with the example code from the last video and this video, you should be able to take that description and write the code for delete. Just do one case at a time, and email me if you have troubles.